I'm just giving this a slightly provocative title because we've been discussing the 2023-24 record warming, but there are some interesting details we need to think about. So this is the surface air temperature anomaly for all of 2023 compared to the base period of 1991 to 2020. As we know already, large parts of India actually cool during the warming period we have seen over the last few decades. The debate has been about whether that's solar dimming because of pollution and aerosols, or is it because of some dynamics. But nonetheless, what is the impact of these cooling on the various disasters we get throughout the year? Could be cold waves, heat waves, cold bursts, extreme rainfall, droughts, landslides, and so on and so forth. And what are the impacts of the gradients that are created in the warming? So one argument has been that the Middle East and Mediterranean warming is so rapid that it's shifting winds here and is creating heavy rainfall over northwest India and flooding in Pakistan, which has been occurring every year since about 2010 or so, and so forth. And global surface air temperature anomalies, again 2023 obviously jumped out of all the previous years since 1940, and it may have crossed something like 1.4, and now there is an article out of by Copernicus arguing that in 2024 we'll end up crossing 1.5. I've discussed this in a previous podcast. And of course 2024 started with the very warm end of 2023 and has remained, maybe didn't break a record every month, but has remained warmer than 2024 and is going to be probably the warmest year as well. Then in this context, are these record warmings related to or causing something over India? Is it related to the strong El Nino we had and a La Nina that was predicted but didn't show up in 2024 so far, and so forth? Difficult questions, but nonetheless, I'll just flash through some nice compilation of disasters, extreme events that Down to Earth always provides. So this is for India 2023, an assessment of extreme weather events, and this is India 2024, an assessment of extreme weather. So they do it for January to September. Even though we have a cyclone season in October, November, this is the end of the official end of the summer monsoon, even though now we know that summer monsoon keeps extending. If you want to read the subtitles, India saw extreme weather events on 86% of the days in the first 9 months of the year, and here it was 93% of the days in the first 9 months. All 36 Indian states and union territories experienced extreme weather events, and here these weather events killed 38 people and affected 3.2 million hectares of crop area. Third one here, extreme weather events have killed 2,923 people, affected 1.84 million hectares of crop area. So here it is 3.2 million hectares, and 35 out of 36 Indian states and union territories extreme weather events. So the distribution changes, duration, intensity, frequency of things change. So here is the comparison. I took it from the two reports. India experienced extreme weather events on 235 of the 273 days. Here 255 of the 274 days. Region-wise extreme weather events from January to September here. Central region, so you are looking at number of days, human deaths, affected crop area, houses damaged fully or partly, and total animal deaths, big and small. So that's obviously a big part of the livelihood for large parts of India. But you can see the same regions light up, and we have already seen that the extremes are stuck in a corridor over here for over a century. If you look at, so this is looking at the central region, and this is looking at the southern peninsular states, and you are looking at the northwest region here as well. And you can compare the numbers, but I'm not going to go into those sorts of details. But basically you can, you don't want to compare year to year number of days affected by the same event and so on. You want to see eventually some trend. If these central regions are getting hit more and more by certain types of events, if for example, heat wave duration, intensity and frequency are going up, if the extreme events in rainfall are going up, or they are becoming larger scale, if they are stuck in this corridor, as I mentioned, are they bringing consistent disasters every year? So we'll see some extreme event type disasters as well. The second part of the comparison here, east northwest regions as opposed to the central northwestern and peninsular regions. If you look at day-wise extreme weather events, again it's for January, February, March, May, June to September, and you have different seasons. So cold waves here, heat waves mixed with some heavy rain, floods and landslide, that's mostly dominant here, but also some here pre-monsoon can wreak havoc. There are cloud bursts embedded in them. You can see that they are far fewer here. And lightning and storms. Lightning is a big killer in India, hard to predict, but there are many efforts being made to set up monitoring networks and providing early warnings and so on. Okay. Similarly for 2024, this is for east northwest, so sorry, skip this one. Day-wise extreme weather events, again same thing, you are looking at lightning, heat waves, heavy rain, floods and landslides, cold waves and cold days, cloudburst and cyclones and snowfall. Okay, so we have complete smorgasbord of disasters throughout the year, seasonally dependent and regionally dependent, because you don't get snow, cold waves, etc. in the south, mostly in the northwest, and you get cloud bursts also mostly in the Himalayan foothills, as we'll see, and so on and so forth. So here you have embedded snowfall within the heavy rain and landslides and floods. You have other events happening as well, right? Lightning can, of course, occur during the monsoon season and so on. So you see that here, lightning and storms. On 176 of 273 days, India experienced lightning and storms. They claimed 711 lives. Here, on 191 of the 274 days, and claimed 1,021 lives. And you can see the various numbers across the states. So number of days with lightning storms, human lives lost, and so on and so forth. But complete country is covered by these, except these regions here. Okay, so they are everywhere. There are hot spots here. For example, Maharashtra loses a lot of people, 100 here, 70 here. That's kind of the largest number. But here in 24, you had 123 in Bihar, 100 over Uttar Pradesh, I think it's 109, and so on. So you get dry monsoon and yet lightning and people dying from lightning being the main cause. Okay, cold waves and cold days, you can see that there are very few occurring here, also in the mountains, but mostly these are the regions that suffer, and you can see the numbers are different. Number of days per state. Here, number of days, the numbers here are only 14, here 40. Was that because of the La Nina, or was this because of El Nino? Clearly El Nino had an impact here, but overall the warm 2023 probably had bigger role to play than here. La Nina hasn't made an appearance yet, but we know that there are differences in the winter patterns over northwestern India, based on whether it's an El Nino or La Nina. During La Nina, there is much more of a north-south pattern, whereas during an El Nino year, it tends to be confined to northwest to central India and so on. I'm being very brief because I just wanted to give you a sense that despite the global warming happening, all the record warm temperatures getting all the mention, India tends to have its own dance, its cooling as a trend, and then it has all these seasonal disasters like heat waves, cold days, cloudbursts, floods, landslides, droughts, and so on. There is a wildfire as well, right? Heat waves get a lot of attention. On 49 of the 273 days India experienced here, 77 of the 274 days. So even though this was a El Nino year, there were fewer days here than here, more almost double. And they claimed 210 lives here, and they claimed 201 lives, so similar numbers. But you can see again the hotspots here. Right, so this is season, heat wave season, and not region-wise. And heavy rain, floods, landslides, again 132 of 273 days, 167 of 274 days. Claimed 1903 lives, 1910 lives, almost the same. And again you can see where the hotspots are. Northeast is always a hotspot, Himalayan foothills are always hotspots, and then there are random events as well over Kerala, which has become a bit of a hotspot as well. This year Wayanad landslides created such horrific death tolls and disaster there as well. Cloudbursts, you can see, basically stuck over there. These are very important and can cause serious loss of life, property, damage to orchards and so on and so forth. 8 of 273 days here, 14 of 273 days with cloudbursts. They claimed 19 lives here, but jumped to 33 lives here. So you had Uttarakhand having some cloudbursts as well. Here it was just the scale being number of deaths, cloudbursts, and human lives lost. Okay, so it was 1, 1, 1, 1, 1, 1, 12, and 30, 2 and 2, and so on and so forth. So the idea is, I really wanted to show this for 2 years, which are both very warm, record warm, but I didn't get the map of temperature anomalies for 2024, which will come at the end of the year, but you can be sure that India would have still cooled just like it did in 2023 while the rest of the world is warming, but there are of course cooling spots over Eastern Pacific and North Atlantic and so on and so forth. So it becomes basically important to figure out what are the region specific local disasters in each season, and what the early warnings needed are, and what the last mile gaps are that are still causing some deaths despite improving early warnings. And we have to see what the skills of the early warnings are. You expect heat wave early warnings to be more skillful than heavy rain events sometimes, because models are much better at doing heat waves. Nonetheless, we are still having lots of unexpected heavy events, not as bad as something like, let's say, Valencia floods, but Wayanad was not predicted well. And then there is the issue of adaptation and resilience, and who's doing what, whether we are doing monocropping on the Western Ghats and making places more susceptible, more vulnerable to landslides, or such heavy rains that are coming now more and more are basically testing the limits of our adaptation capacities as well. We can be sure that we have to do more, but you need hyperlocal risk information to be sure that you are effective, efficient, and investing properly, because you cannot make every place resilient to all disasters, right? You have sea level rise, you have heat waves, you have extreme rainfall or droughts, you have landslides, you have cyclones impacting many regions, and so on and so forth. So we need really hyperlocal early warning systems, vulnerability maps, exposure maps, risk maps, hazard maps, and so on. That was the main point, saying despite all the discussion about record warming and worrying about whether this will happen more and more, we should know that this is already happening more and more. So what do we need to do to deal with what's already happening in terms of day-to-day management and adaptation and resilience going forward on a longer time scale? Okay, so let's leave this here.